Hi, I'm Bob Gatzen, and welcome. I've been fortunate to cover a lot of ground during my musical career, studying, playing, teaching, recording. But besides that, I own and operate a retail music store and a teaching studio. I've had that for the last 20 years, and in the past decade, though, one of my main focuses has been in doing research and development and drum design innovation in the drum industry. And as well as that, I have been building this project studio. I call it Red Eyes Studio, which is where we're actually filming this video. And this is a direction a lot of musicians have been taking in the recent past, these project studios. And this has something to do with tuning, which I'll explain later. The big question here, though, is why do drummers have so many problems with tuning the drums? And the answer really, I think, is quite simple. Drummers simply don't practice tuning enough and don't experiment with the drums enough. Secondly, for someone seeking information about drum tuning, there's really very little out there, and the information is really scattered at best. And thirdly, there's a general lack of understanding about the physics of the instrument, the physical nature, the way it functions. So we're going to try to fix all of that. This first video is about a method for tuning. It will involve some basics in sound design, ear training, and explanations about the actual design of the instrument. I'm really looking forward to sharing my philosophies and experience in drums with you, because I hope it'll have a positive effect on your playing. All you have to do is apply yourself and work at it a little bit. Ultimately, the method should develop a sensibility and control over the instrument. This will hopefully make the drums an inspiration to your playing, and also make the drums feel great to you. Not just okay, but feel great, because the drums should never be an obstacle to playing music. Throughout the video, we're going to describe drums, the sound of drums, based on three basic elements. Number one would be the shell and its components, which are the timbre or timbre producing element. The second category will be the heads and the tuning of the heads. This will be the tone producing element. Three will be the suspension system, the way we attach the drums to the drum set. This will affect performance and feel. We're going to begin with tuning on the toms. Even though they play a less important role on the drum set, they are the place to learn how to tune. Once you know how to tune a tom-tom, all the other drums are much easier. Element number one, the shell and its components. This is about finding your voice by making the right choice. Finding the right drum that satisfies your needs as a player is very, very important. Let's talk about timbre for 1 minute. Timbre is essentially, it's the color of sound. It's the nature of the sound. So when you're making a selection of an instrument for yourself, you have to pay close attention to this, because timbre is something that's consistent throughout the instrument. No matter how you try to dress it up or change it, let's say with head combinations or whatever, that timbre will always be there. So you want to always choose a drum for sound and feel. And you want to use that in your process of evaluation. timbre is in the control of the manufacturer. It's the way the drum is manufactured. Your only control here is choice, and that's what this is about, making the right choice. For the seasoned player who's been through 2 or 3 drum sets and knows exactly what he or she may be looking for, it's an easy job, because all you have to do is find the drum that does the job for you. For the less experienced player, though, my best advice is to evaluate your tendencies, your listening tendencies. Everybody hears differently. For instance, when you put the stereo on in your car, do you put the bass up or the treble up? When you listen to a band, do you focus on, other than the drummer, of course, do you focus on the bass or do you focus on vocals? Do you like to hear hard, aggressive music or do you like to hear lush strings? These are all tendencies that could help you to evaluate the right drum for yourself. Trust your instincts and always listen to the drums. Your adherence to the drum set will absolutely come down to this, because when you get your drum set home, marketing and reputation of a drum or your favorite endorsee wears off very, very quickly, and it'll come down to this single thing: that instrument has to feel right to you. Hey, here's an interesting subject: shell philosophies, and I'll give you mine. Basically, it breaks down to 2 categories: shells that vibrate and shells that vibrate less, or I call them non-vibrating shells. It's a pretty simple formula. I'm going to show you a few drums and describe to you these shell configurations. Shells that vibrate are usually 5/16 or an inch less in thickness. Also, they are unobstructed shells. I call them unobstructed shells because they have no support rings or obstructions inside. They have a wide open surface or a flat surface inside the drum. I'm going to show you this shell, and this is a shell of that design. The shell is very thin, as you can see. It has no obstructions in it. Shell is got a wide open surface in the inside. These are shells that vibrate freely. And shells that vibrate freely have certain characteristics to them. First of all, they're, in general now, they're bright sounding. They can have a lot of snap to them. They're sort of edgy sounding. Especially in the high ranges, these drums can be very clear in pitch, very pure sounding. And also, in low ranges, the drum can sound wide. It can have a lot of spread to it. It can be actually barky sounding down in the very, very low ranges. The drum will support many head configurations simply because the shell is involved in vibrating the head. So 2-ply heads, single-ply heads, or heads with appliques on them, what I call damped heads, all can work in in sort of an optimal fashion on these drums. And if you like to change heads, that's a consideration. Shells that vibrate less, there isn't a distinct line in terms of which ones are non-vibrating and vibrating, but generally, again, shells that are thicker than 5/16 of an inch, that are, say, 3/8 and up, are shells that just vibrate less freely. And these shells have a completely different design to them in terms of, or completely different sound to them, I should say, in terms of their, which is produced by their design. This would be a shell that you can see is much, much thicker than the one I just showed you. And shells like this actually vibrate less. And the concept is that the shell is more of a substrate, something that supports the heads. So the sound of this drum becomes more dependent on the heads. Some of the characteristics of drums like this is that they sound dense. In the low ranges, they can sound really fat, round, have a very dense quality to them. But when you go up in the high ranges, they generally don't have that pitch clarity that the thinner shells have. And they get kind of a blunt sound. It gets a bit more sticky sounding as well. The heads start to really play a completely different role in the way the drum sounds. The other shell that I categorize as a less vibrating shell would be a shell like this. And I call these obstructed shells. Obstructed shells simply are shells that have some form of reinforcement in it that interrupt the surface inside the shell. So the sound kind of bounces around differently, but the biggest effect that rings have is they damp the edges of the drum from vibrating, so they make the shell vibrate somewhat less. This is also a drum that is more dependent on head for sound. And these drums are especially good in low tuning ranges. They sound big and fat in the low tuning ranges. So if you like a boomy, round-sounding drum, this choice might be good. I will tell you, though, that most of these drums, you'll see them in stores with single-ply heads. If you're making a decision, my best advice to you is to buy, go from the retailer, a 2-ply head, and put it on the drum in the store and listen to it, just to make sure that when you get the drums home, you're not dissatisfied with the performance of 2-ply heads on them. It's all a matter of versatility, but versatility only means this here, that any sound can be a good sound. The only bad sound is a sound you're getting that you don't want. So if the drum does the job for you in its configuration and does it well, then this is better than anything that you could get. Those are the shell designs. So we're going to move on to shell materials. Shell materials in construction. Shells are made out of a lot of woods today. Beechwood, oak, maple, birch, poplar, mahogany, even exotic woods like jarrah, ebony, rosewood. But the two most popular shells are certainly maple and birch. Most high-end drums are made out of these materials. And the basic differences between these two categories would be that maple shells are sort of wet, loose, boomy, loud-sounding drums. And birch shells are dense, and I call it the quiet drum because they're much more controlled, they're contained, they have more focus. And that basically covers the gamut in terms of the type of timbres that are available. The surfaces of drums break down to simply this. A shiny surface produces a bright sound, or what I call it a glassy sound. Some people are attracted to that. You might like that. Porous surfaces, or roughed up surfaces, or satin type finishes inside the drums produce a warmer sound. So if you purchase a drum that has, for instance, a shiny surface, and you feel like you want to warm it up, you can, for instance, sand the inside of the shell and turn it into a porous surface and help to warm the drum up. Above all, when you go to pick your drums out, just listen to them first. Don't even ask what it's made out of, because that's really unimportant. It's only for your information. So let's go shoot some hoops. The hoops. Some companies support their drums with flanged hoops, or rolled hoops, we call them. These hoops are made in a way where the hoop starts out as a flat piece of steel and is formed on a machine and welded. They're lighter. They are somewhat less precise, and they have more flexibility to them, which is sometimes good in terms of, let's say, a drum not being perfect. Sometimes the inconsistencies of the drum can work, and the hoop itself, adhering to that, can work better than, for instance, a die-cast hoop, which has less flexibility to it. I think if I were to describe the effect that this hoop would have on the drum is that it makes the drum spread out more. It makes the attack of the drum, the center hit in the head, softer. It also physically makes the center of the head feel softer, so there's a little bit of a pillowy feeling to drums that have flanged hoops on them. Die-cast hoops, on the other hand, which would be a hoop like this, are exactly what they're called, die-casted. These are casted in a formed die. They're very, very precise. The tolerances are much tighter on this particular product than the flanged hoop. And they're stiff and generally just have less give to them. On a drum that's in good condition, these really help the sound of the drum in terms of producing a more defined attack, sharper attack characteristic, although the trade-off is that the center of the head feels a bit more brittle. Some players are attracted to that harsher attack, especially for snare drum instead of tom-toms, and prefer to trade off feel for sound. Element number 2, the head's in the tuning. This is in the control of you. Anyway, this controls the tone of the drum. And the difference between tone and timbre is that tone is a control we impose on timbre. Timbre is continuous. This is how we shade color. This is how we shade the color of the sound. So this is the most important part of the tuning section of the video, simply because this is your control over the instrument now. We're going to start by, in fact, we're going to do this section on the 12-inch tom-tom. The reason for that is that the 12-inch tom-tom is, in terms of tuning ranges, and also the fact that it's generally the middle drum of the drum kit, is the best drum to learn how to tune on. I want you to go out and get 2 single-ply heads, identical heads. They can be coated, they can be clear, as long as they're single-ply heads, and start with 2 fresh heads to go through the tuning process. I'm not suggesting that you play with single-ply heads, but it's the place to learn, because anything outside of single-ply heads are called damped heads. And generally, you don't put damped heads on the top and bottom. You use 2 different types of heads. And that limits the tuning range of the drum, and it'll make your possibilities of finding various tuning regions in the drum less. Now, before we put the drum together, we have 1 head on this, but before we put the bottom head on this, I want to talk to you a minute about troubleshooting the drum. Because many times, if there's something wrong with the drum, it can be a tremendous frustration to you, because no matter how well you try to tune it, the drum may never really tune correctly. So the first thing to do is, this is called a bearing edge. The bearing edge is a lot like the bridge on a guitar. That is, if the string were vibrating between the nut and the bridge, it would be like the flat plane of the head vibrating on top of this bearing edge. So the condition of the bearing edge is very important. Take your finger, just rub it along the bearing edge. If it feels nice and smooth and even, you probably don't have a problem. But if there's divots in it, or you feel kind of a mountainous region going on, then you might want to have somebody take a look at this. I wouldn't advise that you try to fix this yourself. The difference now between trueness and roundness is that out of roundness is impossible to correct. If a drum is literally egg-shaped, not symmetrical, there's really no way to get it back in round. The only way to really evaluate your drum in terms of roundness is to try to measure from opposite points and see if the drum reads the same, reading in perpendicular readings, opposite each other like this. Hoops. You can have a flat drum, but if the hoops are out of true, not flat, then the same thing will occur. No matter how flat the drum is, the shell is, if the hoop's out of true, you can't get the drum in tune. This is something that you can fix yourself, and I want to describe to you how to do that. Take your rim off, remove the tension rods, and you can place this on a flat surface, or relatively flat surface. Do not place it on a glass coffee top table, because most pieces of glass are not flat. So you might want to put this on, for instance, your Formica top on your kitchen or something like that. If it wobbles, then locate by pressing down one side of it on the surface where the bend in the rim is. The side that's high now can be extended off the edge of the Formica top. Of course, I wouldn't advise you doing it on your Formica top, because it'll put big divots in the edges. But you might want to go out in your front step or a piece of concrete or whatever and stick this over the edge and hold it down on one side and give it a little tug, go back in, put it down until you get this to wobble as little as possible. This is very important. Okay, so that's about it for troubleshooting the drum. What we're going to do now is talk about the seating ritual. You can troubleshoot the head to a certain degree. One way of doing that is to simply look at the head from a side angle and see if the distance between the hoop and the flat plane is called the collar. And you can sort of eyeball that to see if there's any inconsistencies in it or if it's higher or lower from one side to the other. Because if the collar's uneven, again, the same thing appears. You'll not be able to get the drum in tune. Symmetry is the key to good tone. We're always working towards symmetry. Let's look at the inside hoop of this right here and the outside hoop. Imagine this being the bearing edge of the drum and this being the hoop of the head. The goal is always to try to keep circles symmetrical. So if you tighten down, for instance, one side more than another, what it does essentially is it stretches out the collar unevenly on one side and pulls the head down like this here. If you do this in the seating process and really whack the head down hard, you may as well take the heads off and toss them and start over again, because the heads will never seat correctly. You'll always be frustrated with it. So this part of the process is very, very important. Rim goes on top of the head. Insert the lugs. It's always good to put a couple of drops of oil on the lugs too, so they don't strip out the inserts inside the lugs. Okay, now what I suggest is what I use generally is a two-key technique. The traditional technique is to tune one lug, go to opposite, then go to the perpendicular lug, opposite, adjacent, opposite. And that pattern will work out okay as well, but I found that by tuning the drum down with two keys, you're actually able to get the head, ensure evenness in the seating process. So now we tune these down, and you can bring them both down until they hit. In fact, you can take all the lugs down until they hit. Now you've tuned all the tension rods down to the point where they're touching the rim. The way to check that is to take the little washer on the rim and tune the lug down till it stops. Done. Okay. All right, now go to the opposite lugs, and if you're doing this on a drum stool, it's kind of, you can use a technique of turning the drum like this if you want to, but if you don't want to get fancy, you can simply turn these lugs down until you get a fair amount of tension on them. Go to the opposite lugs, tune them down evenly, same way, and then go to the adjacent lugs and tune down these evenly each way. This crackling you're hearing is the resin that holds the head in. Doesn't mean that anything's breaking, it just simply means that the resin is kind of like settling in the rim. No big deal. Okay, now go around and give it an extra tweak. This is where this technique works out nicely, because you can go in small increments. You can also do this on the floor. I generally do it on the floor, but this is convenient for some guys. Okay. Check the head to make sure that it's tuned down evenly by not locating each of the spots, but in general, just going around the head and looking for high and low points. High, low. Bring this side up a little bit. Low. There's a little bit of variation, but remember, drums like this with 6 lugs on them only, there's always variation between the actual, what we call the node point, that is where the tension rod touches the rim, and the center between the adjacent node point. So you can get variations in pitch, not a problem. This is typical of the way the lugs are positioned on the drum itself. Okay, all right. Now you've seated this head. Now I want to clarify one thing. about seating. There's a lot of ideas about what goes on here, but I'm going to tell you exactly what goes on when you seat a head. You've heard stories of, having to seat the heads overnight and placing them out in the backyard in 36-degree temperature for 3 days and keeping them in the trunk of your car, whatever. The reality is this here. This is what you're doing when you seat a head. You're taking the formation of this collar, which has been designed to accommodate all drums in the industry. And the diameter of these shells, we call it the OD, the outside diameter, will hit in various places on the head because it varies from one company to another by about 30 or 50 thousandths, as much as 50 thousandths. So the drum will hit in different places. So when you seat this head, what you're doing during the break-in period is you're taking this radius, this curvature, and you're straightening it out between the hoop and the bearing edge. It's becoming vertical. If you just whack it down and then loosen it up, what polyester film wants to do is recuperate. It goes from this vertical position to this position. So that is what the break-in period is about. As you play on the drum and tune the head down more and more, the collar straightens out and then the head kind of stabilizes. After that period now, the head begins to wear out as you deform the center of it. And you have to continue to try to position the head so that you store the excess plastic that you're displacing by deforming the head somewhere in the edges. That's exactly what the break-in period is about. So here's a tip for you. You go into a gig and you want to change heads and you want to use them right away, get out the old hair dryer. Heads are made out of a petroleum product. Heat on petroleum shrinks it. So on a petroleum product, I should say, shrinks it. And you can put this old puppy on, this Sear 100 watt, works real good. And hit the edges. Be careful not to stay in one position because you can actually deform the head. But go around lightly until you feel the head is warm. This will seat the collar immediately, and you can go right into a tuning process. Show you this. Proceed slowly around the drum. And then continue to do that and then feel the edge and feel how warm it is. When it feels kind of warm, you've pretty much seated the head now. The regional tuning method. This is a method that I've designed to explore the possibilities of a drum. Every drum has a number of regions that it'll tune in. Some have 1 or 2, some have 8 or 9. So the way to start is to go to region number 1, and that would be to find the lowest possible pitch in the drum. Detune the head. It's better to do this than one lug at a time because when you detune a lug, the head goes like this here. So again, opposites, 2-key method really helps to preserve the head. Okay, we got it pretty much in its lowest position here. This is now the head. Bring the head to the point where there's just no resonance in it. Bring each lug up. You listen to the resonance, not the attack. Hit at the tension rod that you're moving, and listen for any pitch variation. You have to listen to the resonance, not the attack. Boom. Start to go around in very tiny increments. Remember, circles are symmetrical. Now you're going to continue doing this until there's no distortion in the head and the head vibrates freely. For some people, this is more of a sense than a sound. If you've ever flown in a jet, you're going down the runway, luggage is flying all over the place, the seats are rattling. That feeling when the jet leaves the ground, smooths out. That's what we're looking for. It's a sense that you get when the head gets even. Okay, vibrating freely. I can feel it's vibrating freely. It's not even, but it's vibrating freely. Now, once you have it in this position, we're going to use a technique I call the control rod function. That is, we're going to kick each rod off, tension rod off, until the head flops out, and we're going to bring it up until the head vibrates again. We're going to go around the drum to see if we can get the head down to its lowest pitch, so like this. Now we're getting down there. Now you want to aim for trying to get the head as even as possible. Light taps. Listen to the subtleties in the drum. There it is. That's the lowest pitch this head's going to go down to. Okay, region number 1. What I've done now is I've taken the drum and I've done exactly what we did in the last section to the opposite head, so that the heads are tuned at their lowest possible pitch. Now, this is a time for us to talk a little bit about sound design, in other words, the nature of sound. There are 2 components in sound design that we constantly are changing ratios of. That would be attack to sustain. Attack is the very first portion of the sound. It's actually the stick slapping against the plastic. The attack is what the listener perceives most, and it's what we try to control in sound design the most. Attack can be compared to pizzicato or string sound, pizzicato on strings, to different types of bowing, different types of lipping on brass instruments. Attack is something we're always trying to control. When we go through these regions, what you're going to hear are various shifts between the ratio of attack to sustain. Sustain now is the period of time just after the attack period. It is not the length of the sound. The length of the sound is the decay of the sound. And the sustain period is very important because whenever you increase the sustain of a drum, you decrease the attack characteristics. So now I tune the top head the same, and we're going to listen to the drum. Real fat, low sound. This is as low as this drum will go. Now, this regional tuning method is something I've come up with as a tool for research and design, because in designing drums, I take a real close look at everybody's drums. And to scope them out, I want to find out exactly where the drums tune, what the reaction is to the shell and heads, to the tuning regions, just to see where other designs are at. And it's become a really good tool to learn an instrument. I can scope out a drum in just a minute and know where the drum is at. Ha! So, lowest possible pitch. Now, in this first tuning region, we're going to have the least possibilities because the bottom head is going to be at the lowest. It's going to be in terms of the floor of pitch. The top head, we're going to increase in pitch above it, and we'll always have a low-high relationship, and that's why you'll have a limited number of tunings here. So the first thing to do is, again, to establish this pitch, and part of this, if you want to really explore your instrument, should be to recognize the pitch of the drum. So what I suggest to you is to get a device that has a note on it. This is a little metronome I use, and it just plays me an A, 440. So when you want to get the pitch from a drum, or learn the pitch from a drum, never hit it at the edges, because the edges will have multiple pitches in it. The edges of the head produce overtones. The center is the fundamental. The closer you hit it to the dead center, the more you'll hear the fundamental pitch. So if you want to hear fundamental pitch of the top head, for instance, you muffle the bottom head, and you strike it. It's probably right about there is what I hear. Now, the pitch of the drum, though, because the heads might not be exactly even, could result in a different pitch. Is what I hear. So if you relate this to the 440, It's like we call it a perfect fifth. Do-da. It's actually a sharp perfect perfect fifth. If you go up another half step, we call that a tritone. It's in between there, sort of. So if that's an A, if you know how to go to a piano and hit a keyboard and figure out where A is, go down to a D, and now you know that your drum will go down as low as a D. And you can aim for the pitch in the heads to go towards that pitch to find the lowest pitch. Now, we're going to see if there's another region this would tune with the bottom head at the same position, top head, move it up ever so slightly. When you're doing that, you're listening for a couple of things. You're listening for the head to, again, fall into that sort of evenness, that plane where the head, there's no distortion, and you can feel that the drum is loosening up and starting to sing. Because tom-toms produce a singing quality. That's the function of the tom-toms. This could be another region to tune in right here. This has a little less sustain and a little more attack. Again, you don't have to check the edges as long as you go up evenly. I mean, each lug, just tune. Now you can see we're getting a little bit of pitch bend. This is what I call doggy doo-doo. This is no sound. Terrible. I mean, well, I guess any sound can be a good sound, but not this one. This is region number 2. Remember that the regions are defined by the pitch of the bottom head. So we're going to raise the pitch of the bottom head by about a half step and explore region number 2. The way to do that is to muffle the top head with your hand, strike each lug with the drum key in your hand, and just raise it ever so slightly, just looking for a pitch variation. And here's how it goes. The head should be vibrating freely, and you should hear a clear pitch from the bottom head. We've just raised the bottom head up about a half a step. Now you can listen to the drum, and the relationship between the top and bottom head will now be high-low. The bottom head is going to be higher than the top head because the top head is at lowest pitch. If you want to check it, strike it in the center. Definitely high bottom, low top. So here's the result. We get pitch bend. Boo, boo. The reason for that, of course, is that as you strike the top head, you bring the pitch up against the bottom head being in a different position away from that pitch. And that's what pitch bend is. Some players really like this sound. This might be a region that would work for you. Now, let's bring the top head up and start moving up in small increments and see what we get. Same thing, hit the center of the head and move up each lug until the head gets up to the next position and vibrates freely and evenly. You can hear that the head still has some pitch bend to it, so let's move it up again. Those are 2 regions now with various styles of pitch bend. Again, still have pitch bend. Move the head up one more time. Now we just moved out of region number 2. Okay, this is region number 3. I've already tuned the bottom head up a half step, so we're just going to go to the top head at its lowest pitch. And also, I want to say that I'm going to show you a different tuning technique. It has to do with what we learned earlier, the control rod function technique. It's another way that you can go around and tune the top head, so we're going to do that on this. Let's hit it and see what happens. Yikes! Bad. Now the bottom head is so far from the top head that it's really not very effective in terms of tone. Also, you want to, at some point, document pitches where, let's say, the heads worked well together. And we could do that by muffling the top and striking the bottom. In the center, of course. I hear buzz, so take out your trusty tuner and see where we're at. It's a little flat of the A. It's about in here, maybe B flat. So, it's just for your reference, because if you find a spot that's good, you know that you can tune the bottom head up to a B flat, and then from there, you just look for the spot. So now we're going to take the top head up. And this new technique is to simply use the control lug technique. That would be to loosen and tighten. The reason for that is as you get up higher in the ranges, sometimes the head needs to be kind of kicked around a little bit to get in place. So it's better than just going around in a symmetrical, clockwise or counterclockwise fashion. You can also switch lugs. Now you begin to hear that the drum is really changing character right there. That little tweak of that lug really started bringing it up to a pitch where we're entering a tuning region that's working. This is a tuning region. I call these regions where the drum sings areas of natural vibrations, where the heads, the shell, and everything's kind of jiving. Now the head's kind of vibrating freely. You get a nice open sound, kind of a singing quality to it. There'll be no pitch bend at this point because the heads are up too high. Pitch bend appears at the lowest ranges, or in the low ranges, I should say. You can hear as I'm moving up, I'm actually entering into another region now, and again, the tone of this drum is changing. Still sings, but has a blunter quality to it, shorter sound. So now we're going to make one last tweak to this, and that would be to leave the head at this range, and let's just bring the bottom head up and see if it helps it to vibrate. This is another nice spot. Drum is very pure sounding here, real pitchy, a lot of clarity. And this is where the thinner shell drums that vibrate really kind of shine, this clarity and pitch characteristic in the higher ranges. Very, very nice here. So that takes care of the final region. Now you know how to explore your drum. And I'm going to give you a little tip right here now. One is, don't forget to always tune up to a pitch. Never tune down. It's always never. All right? And I think I'll give you another tip here. In terms of tom-toms, if you play a very busy style on the tom-toms, try to tune the top head lower than the bottom head, down in the low ranges. That'll give the drum a lot of attack and very shallow sustain. And then if you want a more singing kind of open tom-tom sound because you play more spaciously on the drums, then either equal tunings in the heads or the top head a little bit lower than the bottom head. Okay, number 3, the final element, the suspension system. The objective of any good suspension system is to alleviate effects on the tone of the drum. So what it really does is it encourages head phasing. Now let me explain to you what head phasing is. When you strike a head, the head is depressed in the center and it's pushing a column of air down into the drum and moving the head, opposite head, in opposite direction. When the heads are in phase, the two heads are moving like this. So making the heads more alike is very, very important. The more alike they are, the more they stay in phase. The longer the heads stay in phase, the more you get fundamental from the drum and also sustain from the drum. So this produces a singing quality. The problem with some suspension devices is they will impede the vibration of, let's say, the top head. So the top head will go out of phase and the bottom head will actually move slower or faster than the top head, and the drum will sound short. We usually define that as the drum sounds dry or it's not opening up. And if you ever want to check your suspension system, the best way to do it is to simply detach the drum from the stand, hold it between your thumb and forefinger at the rim, hold the drum in your hand and hit it. That's what it should sound like with a good suspension system on it. So you're at the gig and all your friends are coming up to you saying, "Man, your toms sound terrible." But really though, your toms are driving you crazy and you have to figure out how to quickly touch up the toms or quickly tune them, say in between songs or between sets, to get them to a comfortable place again. Let's back up for 1 second though, because I want to explain the process that's going on. Here's a head that we've already beaten to death, and as I explained before, the break-in period of the head is forming the collars to the particular shell. Now we're in the wear-out period, and that means that every time you hit this head, you're deforming the flat plane of the plastic, and this has to be stored somewhere. So when you begin to, your drums begin to detune, what you need to do is find a lug, one of the tuning rods, I should say, that will pull the head down into a position and sort of kick it into place and where it will vibrate as freely as it can. Remember, you're just dealing with the conditions as best you can now. When the head finally gets to a point where you can't tune it, it's time to replace it. It's as simple as that. So we'll start with the middle drum. On my kit, my middle drum is my 10-inch tom-tom. And the reason for that, of course, is that this is home base. So once you get your middle drum sounding right, then the other drums are going to be referenced to that. So first we hit the drum and listen to it. Pretty nasty sounding. Yeah, we really bashed the daylights out of this. Now we're going to use the control rod function. That would be going to one of the rods, detuning the drum very quickly, striking the drum, detuning it very quickly, bringing it up to pitch and listening to the resonance afterwards. So place the key on the drum, and then we'll hit the drum and listen to the resonance, not the attack. We're listening to that little bit of ring afterwards. Now test the drum again. You can see it's been improved just by hitting this lug. In fact, this might be the magic lug. There's always one lug on the drum that kicks the head into place. Your job is to find it. So if that works, then just leave the drum alone. Let's just go around and check some of the other lugs and see if it improves the sound any more than that. Okay, you can hear that some of the lugs, well, you might have heard that some of the lugs actually made the tone of the drum worse. So this lug right here, the first one we went to, we really kind of lucked out on it. Now, if you don't find that control lug on the top head, you might want to go to the bottom head, because the bottom heads do loosen up. And most of us don't pay too much attention to the bottom heads, but in fact, the bottom heads are usually the culprit in terms of bad tone on the drums, because of the fact they're hard to get to. We usually tune them unevenly because we pick lugs that are closest to us, or we ignore lugs that are like close to the drum where you can't get a key in there. So you do the best you can on the gig. You get the bottom head in a position, but every so often you should turn your drums upside down, look at the bottom head and kind of readjust it and check the pitches as we did before. But let's just one time hit the bottom head and see if it improves it at all. Not bad. Okay, so let's say that's where you like the drum. You've made a decision. That's where I want my tom-tom. Now, I'm going to simply quickly go around and quick tune the other drums and try to get them to some sort of, pitch level that relates to the drum that we just tuned. Now remember, there's a relationship in pitches from a musical standpoint, but there's also from a vibrational standpoint on the drums. Sometimes when you have two toms together like this here, one kind of supports the other. You can, if you get them in certain intervallic relationships between the two, the drums will actually vibrate the other drum, making actually the drum sound bigger in the environment. Okay, now go to this tom down here, and we're going to check this one. Now, in larger toms, the bottom head is very often the problem because we generally tune larger tom heads on the bottom at their lowest pitch or just above that. So the tendency to loosen up is there's more of a possibility of it happening. Now it sounds pretty good now. Let's listen to all the drums. Snare drum, the signature drum of the drum set. This is the feel of the drum set for most players, and it's the most identifiable drum. Historically, players that have been recognized for a sound have almost always been identified to their snare drum sound. This is a real specialty of mine, and I could easily spend the next 80 minutes talking about this, but this is a tuning video, so I'm going to just try to give you as much practical information about the instrument as possible. Here we go. Main differences between snare drum and tom-toms. 1. Higher tension tuning in the heads. 2. Top and bottom heads of different nature. Very, very different, radically different in terms of the thickness of the heads. 3. The top and bottom bearing edge are formed differently. The bottom bearing edge is formed to accommodate the snares, which really changes the character of the tone of the drum. And 4, this is the only drum that's made out of metal as well as wood. Okay, element number 1, the shell and its components. We're going to talk about shells first. The variation in diameters in shells can be from 12 inches to 15 inches. Generally, the most popular drum is a 14-inch drum, but as of lately, because of the numbers of designs that we have in the industry, we're seeing 12 and 13-inch drums as primary drums on sets today. Depths can range anywhere from 3.5 inches to 14 inches. Again, the popular variation there would be 5 to 7. Also, the number of lugs on drums are now varying. We're seeing anywhere from 6 lugs to 12 lugs. The number of lugs on a drum really can change the tone of the drum, or I should say the timbre of the drum, and it can affect the drum's tuning drastically. So today, having, let's say, 8 lugs on a drum, the drum today is not considered a budget drum because it doesn't have 10 or 12 lugs on it. The number of lugs on a drum today is generally placed on the drum for its design and to create a certain kind of sound. In our industry today, there's over 300 snare drums now available. So the possibilities and the choices are unlimited for you as an individual. A lot of exploration and experimenting is important here. Let's talk about the lugs on snare drums. The number of lugs, well, years ago, we used to put less lugs on a drum to bring down the cost of the drum, so they were considered budget drums or student drums. Today, the number of lugs on a drum is usually there to determine the type of sound it produces. When you put 8 lugs on a drum versus 10 lugs, for instance, the distance between the lugs is lengthened. So the pitch variation between the node on the head and between the nodes will vary more. This gives us a coarser tuning in the drum and makes the drum sound darker, more biting, more barky sounding. So lugs today are definitely a design characteristic more than anything else. Don't be afraid of buying an 8-lug drum. And the final choice would be solid wood drums. These either can be steam bent shells with reinforcement hoops in them, the obstructed shell design, which is a craze that really emulates from the Radio King, Slingerland Radio King from, many, many years ago. Also, there are block drums that really resemble solid wood drums. Pieces of wood literally laminated together, very thick shells that actually have a lot of resonance due to the density of the wood. The depth of a snare drum, that's playing an important role today as well, because the depth of a snare drum really determines more the feel than the sound. Piccolos used to be considered, that is, drums either 3 or 4 inches deep, used to be considered a kind of an auxiliary drum or an orchestral drum. Today it's become one of the most popular drum set drums. When you have less air volume between the top and bottom head, there's a very distinct, undelayed feel between hitting it and the snares reacting to your hits. This is something that's become very attractive to players today. Also, because of the efficiency in shells, the way they vibrate, the way the lugs are mounted on them, these drums have a lot of power and they record beautifully. So don't be afraid to buy a thin shell drum as well as a smaller diameter drum. Snare mechanisms and the snares. This is a 5-inch brass rolled and welded type shell. And the snare mechanism on this we call this a side throw mechanism. It's a very convenient mechanism because the snare actual throw-off of the snares rides level with the side of the drum instead of, let's say, up and down. So it's convenient. The snares on this are a typical set of snares. They're 20-strand steel snares. We call this music wire or piano wire. But snare wire can also be made of other materials like bronze and stainless, but generally most snares are made out of steel, like this. Okay. Snare strainers like this are called off-axis. That means that at this point, there is an axis created. Once it passes over the top of that axis, it pulls in and just can't pull down. It's a physics thing. They're usually very simple. There's no mechanisms, no levers. And you adjust the snares generally on these mechanisms in the down position and lock it in the up position. These are also wire snares, 20-strand, and made out of steel. Now we have another category called fully extended snares. A side throw type throw off. But what happens here, the tongs of the snare, or the metal ends where the snares are attached, are off the head, and it creates a different type of snare drum sound. They have brackets on the outside of the drum that literally support the tongs so that the snares can be fully extended. There's also a version of this called parallel action snares, where as you release one side, the snares would stay fully tensioned and move up and down in parallel action by a rod that goes across the drum. I consider these snare designs to be a little more exotic. And one piece of advice I'd like to give you is that if it gets the right sound, it's great. But research it carefully. Make sure that you can, first of all, find parts out in the field, find these snares, because a lot of times exotic snare designs are difficult to repair out in the field. And secondly, if you feel that you can't find the parts, then adapting standard snares would be a consideration. You might want to ask the retailer about adapting standard snares on this if you need to do that. Those are the snare designs. Okay, first we're going to talk about the bottom head and its function. Getting snare drums to sound good, I think, is really easy as long as you understand the physics of the instrument. The bottom head is designed to accommodate the snares. The snares have to adjust the amount of throw in the bottom head. So for instance, if the bottom head is too loose and pushes the snares out too far when you hit it, then it cancels the snares out. If the bottom head is overly tight and doesn't flex enough, then the snares get sloppy. Most of us seem to think that tightening the bottom head cleans the snares up, cleans the snare sound up, and actually it doesn't at all. There is a distinct place where the bottom head should be in pitch, and I think it's between an F sharp and a B. So you can refer to your A on the tuner again and try to sing pitches above and below A, and if you can get your head to tune into one of those pitches, it's the place to start. I generally like to tune bottom heads on snares to a G. Now, also, the other factor is the thickness of the bottom head. Bottom heads range from 2 to 5 thousandths thick. We call them mil. 2 mil, 3 mil, 4 mil, 5 mil. The 2 and 3 mil are the popular ones. The 2 mil are considered the thinner heads, and they open the drum up and make it spread more. They also increase snare sensitivity. The 3 mil heads box the drum up a little bit. They make the drum sound more contained. They're especially good for hard hitters where they're really pushing the bottom head out, and we're looking for more focus at high volumes. This particular drum is going to have a 2 mil head on it. So let's get it up to pitch. Now, you have to always listen to the pitch of the bottom head, because the bottom head being thin, the lugs, the tension rods, I should say, have you can't feel the tension in the head as well as you can with a thicker head. So you can very easily over-tension the bottom head if you don't pay attention to pitch. So let's get our tuner. Hey, here we go. So if we want a G, it's one step below. Ba-doo. So let's aim for that now. And we already have this head installed. So we're just going to sort of tune it up and bring it up to pitch. Now you might hear pitch variation in the snare beds. That's kind of typical because remember the head, the bearing edge on the bottom has a cutout, and that means that you'll get some pitch variation at the snare beds, but get it as close to a single pitch as you can. So now we're going to apply the snares. This is an area where a lot of drummers have problems. So let me show you a few things about this. First of all, the means of attaching snares to the butt end and the snare strainer are either by cables, which would be stainless steel or possibly made out of a twine rope, or straps, which are typically nylon or plastic. Now the straps are generally used because of their convenience. They're easy to replace, they're very, very durable, but they lack lateral adjustment. And lateral adjustment is very important in snares because snares are not only a tone generator on the drum, they are also a tone control. The amount of pressure you put against the bottom head with snares controls the tone of the drum because it can muffle the bottom head. It actually acts as a muffler. So getting the snares to vibrate freely and evenly is our goal here. Now, we're going to install these with the strap, and I'm going to show you what I mean by lateral adjustment. Lateral adjustment are the snares turning this way or that way. When you have ropes on each end, you can literally adjust the amount of pressure in each direction. That's very important because you have to tighten the snares according to the loosest snare wire. So for instance, if you tighten the snare down like this, the outside snare is very tight while the inside snare will be very loose. The result is you continually pull the snares down tighter against the head to tighten that loose snare against the head, and you box the drum out. So let's install these snares, and we're going to use the strap method. Now there is a little bit of adjustment in straps. That is, if you tug the strap to the right or the left, you can literally change ever so slightly the lateral position of the snares. So you might need to try to tweak that. Hold the snares in the center of the head, and if you don't center them, at least get them closer to the rear, to the butt end, because the snares will stretch out after a while, and straps will stretch out and pull towards the strainer, so they'll stay in position and adjustment longer. Okay, now center them, put some pressure on the opposite tongue, pull on the strap, and get them in position. Now what I generally do is I put a little bit of pressure against the butt end so that I can move the strap through it, but with a little bit of friction, so it holds it in place. Now I'm putting pressure here, I'm pulling it here, I'm checking for lateral adjustment, it looks good. Now just let go of it, and then whack this side down. Okay, now go to your opposite side, put your strainer in the down position, insert the snares, which I've already done. It's in the down position, pull the snares up tightly, and also make sure that your adjustment screw is fully extended. This will give you maximum adjustment over a period of time. Same kind of thing. Put a little bit of tension on the hold down plate, pull the snares down, and then whack this side down. Now the snares are fully adjusted. Okay, so here's another tip. If your snares are adjusted correctly, here's a way to check the bottom head without having to take the snares off. Put the snares in the down position, take a stick, take the snares off the head. Now you can go around. A was our A, we're looking for G. Okay. And also, whenever you test snare drums, when you're making a snare drum selection, test it with your weak hand. Snare drums generally, in my opinion, sound good in either thirds, fourths, or fifths. There are a lot of snare drum tunings, but this is a place to really get started. So you want to try to recognize a pitch a third above. So we got the G here. Da, da, would be the third. So we're going to aim for which is actually right now high. Now, once you've kind of got it in the ballpark, go around and look for high and low spots again. Low. Let's bring the side down. Remember, down, then up. Okay, pretty close. Low tunings like this will generally give you a fatter sound, a woodier sound from the drum. Again, the attack sustain concept applies. This would give you less attack, more sustain. And if you really want to hear or test the snare drum, you really want to hear the meat of the snare drum, just hit it lightly in the center. You don't have to kill the snare drum, although when in your final analysis you want to test it at all volumes. I'm not going to bash this drum, but okay. Also, you want to test the snare drum for stick click, because higher tunings will create a different type of stick click. Sometimes that'll be preferred. Okay, now let's take this and move this up a half step. So, now we're going to go up to this pitch, and now we're at, between the bottom and the top, we're at a fourth. Remember, this is an 8-lug drum, so this whole thing of some variation in pitch between the lugs is very common. As the drum goes up higher, the drum will start to get more of a pop sound to it. And it'll get a pitchier kind of tone to it. When you tune in low tunings, when you hit a rim shot, you get a crack sound from it. When you tune it up a little higher and it starts to get more pitch oriented, you get a pop from it. Now, tuning like this has a really nice balance between attack and sustain, because it's, again, one of those tunings where the drum generally sings, just like the tom-toms. So now we're going to bring it up another step, and we're going to go to fifths between the bottom head. So the fourths were ba da da da, the fifths. Just go around slowly. And now the drum's going to have a very short sustain period. It's going to have a very pointed attack. Also, the stick click will change in higher tunings. This is a place to start. There are other tunings that work for special effects, and also muffling plays a role on tuning as well. Lower tunings generally require some sort of muffling to keep the drum from being too sloppy. Hey, element number 3, suspension. There's not a whole lot to tell you about suspension of the snare drum. It's just this one thing. The claws of the snare drum basket, don't tighten them against the bottom head. It impedes the vibration of the bottom head and actually boxes the drum out. You want it to float in the snare drum stand. My final tip, be as subtle as you can with muffling. Remember, muffling is a form of damping and cuts down the volume of the drum. Ah, yes, the bass drum, the most prepared drum on the drum set. One of our primary goals with the bass drum is to attain fundamental pitch and low frequency in the drum. The other objective is to muffle this drum correctly. It's the key to getting a great bass drum sound, and it's going to be the main topic of our discussion. Also, this is the only drum on the kit that we hit in the same place all the time, so we can depend on a certain consistency in sound. And speaking of sound, unlike the toms, which have a singing quality and function in the music as a phrasing device, and the snare drum for its accenting and outlining quality in the music, the sound that we aim for, the quality in the bass that we aim for in a bass drum, is a throbbing or pulsating feeling. It's the engine of the train. Also, it's the second most important drum in terms of the feel of the drum set. So let's move on now to element number 1, the shell and its components. Shells on bass drum are generally made of the same type of laminates as the tom-toms, but thicker, more laminates. And that's to support the diameter of the drum, the spurs, which hold the drum in position, and sometimes tom-toms, which are mounted into the drum. The length of the drum is just like the effect we talked about in snare drums on piccolo snare drums versus deep snare drums. It affects the feel of the drum more than anything else. The longer the drum, the more delay you have in terms of pushing this air back and forth. So longer drums will create low frequency because of the length of the shell, but the pitch of the head always remains the same. So if you're a hard player and you want volume and you're able to really push that much air, you generally will aim for a longer drum. But if you're a more delicate player, and especially for recording, shorter drums can really sound great. So you have to examine length according to your style. Okay, element number 2, heads and tuning. Let's talk about the batter head first. Batter heads for bass drums now can be bought muffled. That is, they would have some form of muffling at the edges, which removes the overtones and brings out the fundamental pitch, as we discussed before. Also, there are devices out there that can be adhered to a traditional head to muffle the edges. So it's a good idea to put on a prepared head to start with, even before you muffle that head, just to take the overtones out of the drum and enhance the fundamental pitch. You have a choice of 2-ply or single-ply heads usually. Most players will use 2-ply heads because of the durability. And also, 2-ply heads generally have more slap from the pedal because of the thickness of the head. So there's a little more definition. Single-ply heads, on the other hand, can have a much sweeter attack and create more woof in the drum, more low end in the drum. Okay, front head. You have to decide whether you want a vibrating head system or a non-vibrating head system. We're going to show you this drum today with mufflers in it without the head so that we can show you muffling techniques. But let me tell you the difference between the two styles. If you're going to put a front head on and you want it to be a vibrating system, then any hole that exceeds this size, which is about 6 inches, will vent the drum to a point where it will start to turn the drum into a single-headed design. Also, if you place any hole in the center of the head, it will stop the head from vibrating totally. So if you're going to want some vibration or resonance from the front head, then you need to place a hole off-center as far to the edge as possible and as small as you can live with. That will give you maximum vibration, other than not putting a hole in the head. Most of us put a hole in the head because we never know if we're going to have to put a mic up inside the drum or not. This is what's used. This is the most popular setup and what's most commonly used. If you're going to cut a hole in the center, you can cut any size hole. Here's a head that's completely cut out. We only put this on to put the hardware back on it. But you could cut a 6-inch hole in the center or a 12-inch hole. It won't matter at that point. You'll be going for a single-headed sound. Single-headed sound is a more blunt sound. It's got a lot of attack to it. It's very controllable. It's good for miking very close up. In other words, sticking a mic up right close to the head. There's not too much shell resonance, so the mic inside the drum really isn't picking up shell resonance as much as it's picking up attack. But in a double head vibrating system, we have resonance in the shell, and the miking techniques would change for that. Also, pure acoustic volume, that is, pushing the air with a double-headed design, would be much more efficient and less directional than like a single-headed concept. Again, it's application more than anything else. Also, front heads should be muffled, because if they're not muffled, they can be boingy, and that will also detract from the fundamental pitch. Some heads, like this one in particular, have a muffler built into it. You can also put a muffler up against the front head, but you should muffle at least the edges of the front head or put something up against it. As far as tuning is concerned, I think this is the easiest drum to tune, because there's only a very small region where the drum functions properly. Front head. If you want the lowest pitch from the drum, it's just got to be flopped out to the point just before it starts to rattle. If you're muffling the front head with something against the front head, generally you can even get the head down lower because it will take the rattle out of the head. Remember now, the seating ritual still applies here. Got to whack the heads down, and especially on bass drum, you have to hit them hard because they've got a lot of layers of polyester film that you have to form in a very long and distinct collar formation. The back head essentially has two tuning areas. It has an area where it's just before it wrinkles, and it's it's very lowest pitch and almost has no resonance. And remember, again, it's still this whole thing of sustain and attack. This concept of sustain and attack applies. When the head is flopped out, you get a lot more slap from it. Bring that head up just ever so slightly until it starts resonating. Because of the size of the head, it overemphasizes the woof in the drum immediately. Just a couple of turns on the keys. So you have to decide between attack, sustain. This also affects the feel of the drum as well. If you tend to play into the drum, generally you like the head to be as dead as possible. That would be the toe technique, where the toe is up and played into the drum and the pedal stays against the head. If you play a technique either heel down or a toe technique where you bounce the pedal off the head, you might go for a slightly higher tuning to create more liveliness in the head and to create more sustain in the drum. The control in muffling has to do with, again now, both feel and attack and sustain. Muffling, most mufflers are fabricated by individuals. These are commercially made mufflers, and the way they function is they bounce off the head. And I believe that this is the best kind of muffling. And you can do the same thing by simply wrapping up a towel and putting some duct tape down and getting into position and have it fluctuate with the head rather than putting constant pressure against the head. If you want to get more tone from the drum and character from your particular drum, you want this to bounce away from the head so the head vibrates and lets the shell work for you. So we're going to start by putting one of these mufflers in, and the two controls we're trying to apply to the head are pressure and the coverage of muffling. In other words, how far up the head do we want to put the muffling? This would be something I consider to be the minimal amount of muffling. First, I'm going to hit this drum without a muffler in it. And you can see, without the drum prepared, it's pretty useless. Yikes. Pretty nasty sound. Okay, so we drop this in. You can see that it's about a third, or maybe 25% covering the head. Now watch what it does to the tone of this drum. Definitely cuts the volume down, but certainly makes it much more focused. Listen carefully. Okay. Now this back head is still pretty lively. So if you're a toe-up player, it could be too lively for you, because if you leave the pedal into the head, the pedal will chatter. Now I'm going to install a second muffler in the bass drum. Now you can do the same by perhaps using a more substantial towel or whatever you decide to put in there. This puts more pressure against the head, but the same amount of coverage. And what this will do, this will dry the drum out. It'll take a little more of the bottom. It'll tighten the woofiness of the drum up and bring just a little more attack. And that's why I said listen carefully to the first hit. So here we go. This also will affect the feel of the head. Now, the third position will be to put more coverage against the head. In other words, instead of covering 25% of the head, we're going to cover maybe 35 or 40% of the head. We'll have to install another muffler to do that. Now, by doing this, what we're going to do is we're going to bring out optimum attack. It's going to hear more of the slap of the pedal. It's going to definitely dry the bottom out of the drum. It's going to make the drum sound less woofy. This is a technique we generally use for inside miking to really control the bottom of the drum, tightening up the bottom. Here it is. This will give you maximum attack and less woof. More attack, less sustain. That principle is always there. Hey, remember I told you that polyester film is a petroleum product. The worst enemy of this type of product is heat. Heat buildup is the primary cause of head failure on drums. And since we hit it in the same spot all the time, and if we play furiously on the bass drum, heat buildup will indent the head and you'll blast through it in a minute. Make sure that you check and you have not worn through whatever you're protecting the batter head with. And finally, element number 3, suspension. This is pretty easy. 2 things. Try not to put tom-toms in the bass drum, if you can live with that. Putting toms in the bass drum, putting weight on the drum, affects the way the shell vibrates. Secondly, try to mount the bass drum as evenly front to back to the floor as possible. The more you tilt the bass drum back, the more you put pressure on the back rim. The only reason we usually tilt bass drums back is to create a certain feel in the beater. And if that's the reason you do it, then fine. So look, practice your tuning, but don't get crazed over all this stuff. Don't get obsessive about it either. Apply yourself. It's really going to be well worth the effort. Remember, it's about playing music, playing the drums, and especially having fun. 1994, we shot Tuning, Sound, and Design, and I must say it has far exceeded my expectations. Tuning, Sound, and Design is now on the Warner Brothers bestseller list, and all I can say is, you guys got to get a life. No, really, thank you. Naturally, I've come away since then, invented a lot of drum stuff, learned more about drums, and importantly, more about you. I've come to the realization that unless the drummer has experience on a melodic instrument, it's extremely difficult to develop an ear for pitch, especially from tuning a drum. The fact is, drummers are not likely to sit at the piano and practice pitch recognition. However, I strongly suggest every drummer play a secondary melodic instrument. In my case, I devoted 10 years of my life to playing vibraphone, which has been an invaluable resource. The inspiration for Drum Tuning Simplified comes from your feedback and my experiences having to tune drums in distracting and noisy environments. How do these two things relate, you ask? Often, I am tuning drums at music trade shows, percussion conventions, festivals, backstage while other bands are sound checking, you name it. Under these conditions, I've learned to rely on certain techniques that I now realize are key elements for a simplified tuning method. The association of feel and sound will benefit any drummer that is struggling with tuning. You know, like about 90% of us. The techniques I'm about to describe is a method to get your drum sound into the ballpark, so to speak, setting the stage to hearing the drums in a way that allows final tweaking of the sound. It works for me. There's no reason why it shouldn't work for you. Now, I'm not suggesting tuning drums by sight and touch is an end-all. It still comes back to developing your ears, but I believe this is a great way to get started and a vital supplement to the full-length video. Please, do not overlook the complete DVD package, as it will provide a solid foundation to achieve total control in developing the sound you desire. Also included is additional performance footage. As much as I like to talk about the technical aspects of drum physics, I find this type of information confusing to most drummers. Practical information is far more effective, for without it, you'll find yourself back in the same place, not being able to tune your drums on your own. Don't forget to take your Dramamine. There are going to be a lot of fast cuts in this video. Okay, you with me? Let's get started. There are 3 key facts to drum tuning. Now listen carefully. Number 1, regardless of the condition of the drum, the single most important element of drum tuning is to create equal pressure in the mating of the counter hoop to the head, bottom line. Extreme variations in tension rod pressure are absolutely voodoo. Number 2, the key to a great drum sound is symmetry, roundness, and flatness. I don't care what a shell is made of. If it's relatively round with flat bearing edges and equal tensioning is achieved, it will produce a musical tone, an acceptable drum sound. Unfortunately, it's not a perfect drum world, so we must learn to make the best of circumstances. Number 3, know where your drum is at. Now, you're going to hear me say this many times because it's so important. Don't beat yourself up if you can't tune your drum. It may not be your fault. The mystery of drum tuning largely relates to discrepancies in the drum or the drum head. And yes, you can do this at home without professional help. So let's jump to this little demo on how to troubleshoot your drum. Measuring the drum for roundness is simple and revealing. Remove both drum heads. Place the tape measure over the bearing edge and rotate the opposite side of the measure back and forth like a pendulum until you find a center point, like this. Make note of that measurement. See, this drum measures 11 and 13/16 of an inch. Now, rotate 90 degrees and repeat the process. Wow, the reading is the same. This is a good shell. However, if the two measures vary by an 1/8 inch or more, then your shell is out of round to a degree where accurate tuning will never be achieved. A 1/16 of an inch out of round is acceptable. This information will eliminate all guilt and possibly frequent visits to the loony farm. Unfortunately, there's no way to correct this problem, but at least you'll know where your drum is at. Now let's measure the drum for flatness, again with the heads removed. Place the shell on a flat surface, not glass. Often, glass is not flat. Unless you happen to have a machinist granite block in your house, for now, a Formica countertop will have to do. If possible, place a light source over the drum. Using both hands, one on each side, try to rock the shell back and forth. Check this out. If it rocks, then the shell is out of true. In other words, the bearing edges are not flat. Grab a few sheets of common pad or copy paper and slide as many pieces layered together between the bearing edge and the tabletop as you can. If the layers exceed 3 sheets of paper, you will find it difficult to tune this drum. A sheet of paper is approximately 10/1000ths of an inch. The good news is a professional drum mechanic can fix this problem. Head deviation. Ooh, sounds kind of dark, huh? Actually, it means variation of a fixed measurement. When installing a new head, run your eyes along the collar area of the head. Now, I purposely tune this head unevenly, so if you're able to see high and low spots, then the head may not tune very well. If there's a discrepancy, mark the high area, and once you tune the head, keep an eye on that area for problems. You need to know where your drum is at. Proper head fit in the counter hoop. Place the drum head into the counter hoop. It must never be forced into the hoop. Check it out. This is a tuning death wish. Hoops are often not around, so you want to locate touch points along the edge of the head. Place the hoop under your foot and pull upwards with a slight tug. Continue this process until the head drops into the hoop with absolutely no resistance. Even if the head fits nicely into the hoop, get out the old tape measure and measure the hoop for roundness, just like we did the drum shell. Flatness. Since we're on the hoop topic, you should check for flatness as well. Place the hoop on the countertop. Position your hands on each side of the hoop and try to make it wobble. Hold down the hoop at one side and try to figure out where the hoop is distorted. Place the hoop over the edge of the hard surface. God, not your countertop at home. A workbench would be more appropriate. Give it a little push. Keep doing this until the wobble disappears. Tap testing drum heads. This is a highly controversial topic. I've tested thousands of drum heads, and from my experience, tapping a new drum head does not necessarily reveal the quality of tone it will produce, unless the tap produces a completely dead sound. If the head taps dead, it will always produce a dull and thuddy tone. In other words, a no-good head. Essentially, the tap test is most effective in determining whether a head is completely defective. Tapping a head that has been mounted to a drum, however, is useless. Alignment. Look carefully at the tension rods from the side of the drum. They should be straight up and down vertically in relationship to the shell's surface. Loosen all the tension rods and shift the counter hoop back and forth. It should move freely. Tension rod misalignment exerts pressure on the shell and can make tuning difficult. If you want to keep your sanity, troubleshoot your drums before you turn a single tension rod. Know where your drum is at. Hey, go grab your favorite cap. This is mine. What do you think? Can you tell I wear it a lot?
It's a beautiful day in the neighborhood.
All right. Sounds like Mr. Rogers. Sorry. When you slip your cap on, you intuitively center it on your head, like that. Now, if you push your cap to one side, how's that feel? Perhaps fashionable, but not very comfy. Okay, center it again. You notice, you wouldn't hold your cap down on one side and try stretching it over to the opposite. Instead, you shift your cap back, naturally to center it. This is exactly what happens to the drum head when you are tuning it. To center the drum head, you should detune one side while tensioning the opposite side. This centers the drum head by shifting it instead of stretching it. Polyester film is really tough stuff, and it doesn't stretch very easily. Just remember how you make your hat feel great. Now let's make your drum feel great. While we're on the topic of comfort, here's a key issue. Spend a few extra bucks and pick yourself up a quality drum key, like this one. The key should feel comfortable when held between your thumb and middle finger and spinning it on the tension rod. It should be something you don't mind carrying around all the time. Incidentally, if you don't want to carry the industrial version around, check this out. I carry this little one around unhooks, it opens up like this, and there you go. I put it in my pocket, have it on. It's drum jewelry. That's what this is, drum jewelry. All right, all right, all right. I know I'm anal about drum keys. My theory is pay most attention to the drums you hit the most. That would be the bass drum and the snare drum. If you don't get this right, you'll never fall in love with your drum set. For some reason, drummers don't pay enough attention to the bass drum, and they get hung up with the toms. It's like very weird. The bass drum is the heartbeat. It sets the tone and feel of the kit. Unfortunately, it's not an easily replaceable component like the snare drum. So if you aren't happy with your bass drum, you'll probably never be happy with the kit. The good thing is, it's the easiest drum to tune, so we're going to work on this first. You ready? Often drummers get locked into certain things and are afraid of change. Hey, like who isn't? Come on, change is scary. But don't be dopey about new product technology. Bass drum heads are not your father's Oldsmobile anymore. I'll be showing you Evans products throughout the video, but rest assured there are other fine products to choose from. Let's begin by getting the heads tuned as low as possible. Here's how I do it. Place the head on the bearing edge, spin it or shift it back and forth, like this. Make sure it's laying evenly on the edge. If the head does not lie flat, then keep in mind that additional tension will be required to seat this head. On the other hand, if it does lie nice and flat, then it's best to bring the head up to the desired pitch or slightly higher. Play on it and then retune. It's not a good idea to over-tension a new head. Install both heads. Place your thumb on the counter hoop and your fingers along the head hoop. Tighten the tension rod until you feel the head move along your fingertips. Now go to the opposite side and repeat the process. Then again, 90 degrees, until all tension rods have made contact with the head hoop. Feeling the hoop of the head moving along your fingertips tells you exactly what is happening. Now place your palm on the counter hoop and apply downward pressure by leaning into the drum with your forearm. Tighten the tension rod until you feel the head move along your fingertips. Repeat the procedure at the opposite side, then at 90 degrees. Now tension the remaining rods in a staggered fashion. Make sure you don't tune rods you've already completed. Establishing equal pressure on each tension rod is crucial. If you feel excessive tension at a particular key, then something's going wrong, and you should troubleshoot the problem by checking for thread binding or misaligning of the tension rod. This is exactly why touch tuning is effective. Regardless of how much resistance you feel at the tension rod, touch tuning allows you to feel precisely how much the head is moving. Position the drum under a convenient light source, like overhead fluorescence or the sun. If you're using a clear head, you should see a reflection on the head surface as you're standing over the drum. By the way, if you're using a coated head, you must position the drum to create shadows. With both heads fully tensioned, place your palm in the center of the head and push down using your forearm and upper body weight. While maintaining pressure on the center of the head, detune each tension rod until you see the wrinkles stop moving. Then tension up carefully until you see the wrinkles start moving again. Continue to maintain pressure at the center of the head and repeat the procedure at each tension rod position. You can use any tension rod sequence you want, but do not repeat yourself. Now here's the cool thing. Release the head pressure, and like magic, the wrinkles should disappear. Repeat the process for the front head. This estimates the lowest possible tuning of the head, and now all you have to do is tweak it up gently until it feels and sounds good. Okay, while tapping the head with the bass drum pedal, loosen the tension rods until the head sound flattens totally out. Then, select one of the tension rods at the top of the drum and tune it while you're tapping. You should hear the drum begin to resonate fully, and the feel becomes more bouncy. If this tickles your fancy, then loosen the same key rod and slightly tune each tension rod up until you feel and hear the same results. You want to make equal pressure against the head. Once the head has been evenly tuned, I often go back and forth between a flat sound and a resonant sound very quickly by turning 1 or 2 tension rods. Let's tune the resi head now. I'm going to need some help with this. Can one of you guys come out here and give me a hand? Position yourself directly in front of the drum and detune each tension rod until the head rattles. Then tension it back up until it disappears. Tune it until you hear something you like. Keep messing with the keys. Mess with the individual rods and listen to the effect they make. There's always a magical tension rod that does the trick. And I wish I had a formula for this, but it's really a matter of trial and error. If you don't like internal muffling pads against the head, then at minimum, place an absorbent material in the drum, even if it doesn't touch the head, to produce a rounder, denser sound. This also affects the way the drum feels. Muffling the front head will lower the overall pitch of the bass drum. Check it out. With a pre-muffled batter head like this one, a cool technique I often use is to place the pad only on the front head while leaving the batter head wide open. This produces a natural airy tone with a sharp attack characteristic. A boomy bass drum sound by itself is great, but unfortunately it's not very useful. This combination will provide a big sound with enough control. The final touch, head protection. Since there are no state laws on drum head protection, you can do whatever you want. But if you want to protect your $40 investment, put a protective patch on the head. There are many choices, and each will offer various degrees of protection along with sound and feel possibilities. Here are 3 to check out. The clear patch. This offers the least amount of protection but preserves the natural feel and the sound of the head. Since I'm pretty easy on heads myself, this is my personal favorite. The Cordura, or fabric patch. This preserves the natural feel, but produces a slightly softer attack characteristic and has moderate durability. And finally, the Aramid patch. This is a Kevlar type patch. It offers maximum durability, usually the life of the head. The beater response is a little less bouncy, but creates way more slap in the attack characteristic. There are more tips on the tuning, sound, and design video, so don't forget to go to Bass Drum on that menu for complete tuning and muffling information. Okay, this is one of the biggies. Plain and simple. If you know where your drum is at, then the only variable that remains is the drum head. I hate to say this, but the drum head is largely responsible for the so-called tuning mysteries we encounter. You see, every drum head has a certain percentage of deviation. Ooh, there's that word again. A head that is highly deviated affects tuning in the same way when the bearing edge isn't flat. This means that each and every time you put a new head on your drum, it will behave differently depending on the condition of the head. This is what puzzles the drummer and why drum head manufacturers work intensely in producing consistent heads. Also, as the drum head wears out, it's crucial that retuning be maintained in a way that evens the head out. Otherwise, the head will become overly distorted and impossible to tune. When I'm building a new drum, like a prototype, I look for the roundest shell and counter hoops as well. I cut the bearing edges as accurately as humanly possible and make sure all the hardware is perfectly aligned. However, when I'm testing heads, I conduct those tests on the same drum, and it's usually one of my prototypes. Are you with me? Do you understand what I'm saying? The drum is the constant and the head is the variable. Have a good head day. Wrapping your arms and legs around a snare drum is a little like riding a great horse or a tricked-out Harley Davidson, so you want to get this right. The beauty of the snare drum is that unlike the toms and the bass drums, the snare drum is a replaceable component. There are thousands of choices out there. Having a few snare drums around can really change up the kit and keep you motivated. Due to the higher tensioning of the snare drum, touch tuning becomes secondary to eye tuning. Let's repeat the process we use for the bass drum with one exception. Apply additional downward pressure from the palm because the snare drum requires much higher tensioning. Go for it. You can't apply too much pressure. Okay, let's tune the snare head now. If you do not have a pitch source, tension the snare head using quarter key turns, one full cycle around the drum at a time. After each tuning cycle, place your thumb onto the edge of the head with your forefinger under the hoop and apply downward pressure into the head with your thumb. When the head reaches a proper tension, it should feel like you're pressing down on the surface of a volleyball. A little bit of give, then a feeling of it stopping. Continue the tuning cycle until you sense this feel. Tension the batter head in the same fashion until it is pitched higher than the snare head. Unlike the snare head, you should sense very little give from the thumb test. It should feel like you're pressing down onto a fully inflated bow basketball. If you have a metronome with a pitch source, it's usually an A or a B flat. Set the metronome to play a constant pitch and begin tensioning, being very careful to meter quarter turns of the key. Imagine preparing 8 identical desserts and you're applying the whipped cream, making each one look exactly the same. Learn to make identical key moves. While tapping the edge of the head, continue tensioning until you match the pitch of the metronome by moving around the drum sequentially, clockwise or counterclockwise. As the pitch of the head gets close to where you like it, go to smaller, 8th key turns to tweak it in. Describing the touch in touch tuning is extremely difficult, but after a while you will sense the amount of pressure as it relates to sound. For instance, I can tell if the snare head is pitched too high or low just by pressing into it with my thumb. Now, go to the main menu, Drum Tuning, Sound and Design, and click on Snare Drum for more details. Now we'll do a visual inspection of the snare drum to check our work. With the light source in place, view the snare bed area and make certain all the wrinkles disappear. Now this might require additional tensioning of the head, but usually you can detune again without the wrinkles reappearing. It's a stretching thing, you know? It's very important now. I do not recommend excessive tensioning for seating, as this can often damage the head, especially the thinner snare drum head. It is always best to set a marginal tuning, play the drum for a while, and retune. If time is a constraint, then tension the head a little higher than the desired tuning range and then detune. Do not slam the head down with a torque wrench. You're not changing tires on a NASCAR. Focus your eyesight along the head surface, measuring the distance between the head and the top of the counter hoop. Now don't get anal about this. You don't have to get out a ruler. You can rely on your eye drawing a straight line from the head surface to the hoop edge. I'm using a ruler just to give you a clear depiction of it. Spin the drum around and look for evenness. You want to pay particular attention to the contour of the snare bed and take note of high and low spots. Make certain the hoop is even on each side of the snare bed's contour. Remember the head in the hat concept. It may be necessary to loosen the adjacent or opposite tension rod to pull the head over to one side. This is a critical measurement because it controls the snare wire action. Let's talk about the snares for a moment. Throw the snares on and make sure they are properly aligned while under tension. Now throw the snares off and see if all the snare wires lie flat and none of the individual snare wires are distorted. Once the snare wires become distorted, in fact, even if one snare wire is distorted, more pressure will be placed against the head, and this will make the drum choke. If you want your snare drum to sound the very best, replace the snares when they look like cooked spaghetti. Flip the drum up on edge with the heads facing sideways. Slowly spin the drum like a wheel while eyeballing the distance between the tension casings and the bottom edge of the counter hoops. The lug casings should be nice and even relative to the bottom of the counter hoop. You can expect the bottom hoop to be a little closer to the casings due to this thin snare head stretching out. The snare head is 5 times thinner than the batter and will easily stretch out. The final view is to measure the amount of threads exposed in each tension rod. They should be similar, give or take a few threads. Snare hold downs. Now you may think this is unimportant, but it's very important because it controls the amount of pressure exerted to the bottom of the snare head. Okay, I have to hip you to this. Get rid of those white plastic snare straps that come packaged with generic snare wires. Whew, gone. This material is way too rigid and chokes the drum. Again, too much pressure against the head. Replace them with reinforced packing tape, black nylon straps. You can find these at fabric stores, or snare cord. Here's how you adjust snare tension. Throw the snares on and while lightly tapping the center of the batter head, tighten the snares until they sound crisp. And then over-tighten them until it makes the drum sound dull. Now loosen the snares while tapping until you reach a spot that feels and sounds good to you. There we go. You might find this helpful. Once I have my snares tensioned properly, I often tune the drum with the snares on. This way, I get a true depiction of how the drum actually sounds. When it comes to muffling, my philosophy is try to use a prepared head. That would be a pre-damped drum head before applying additional dampening. When it comes to externally mounted dampeners like rings, gels, duct tape, feminine napkins, okay, that's enough. I draw the line now. I just want to say, less is best. I'd love to show you all the creative dampening methods I've run into, but due to time constraints, I decided to show you a product I recently created for Evans drum heads. Check this out. It hooks onto the hoop and can be thrown on and off very easily. Pretty cool, huh? This method is minimal and totally adjustable. You can simulate something like this on your own, or you can spend a few bucks and get the real deal. Yeah, right. It is patented, by the way. You know how drummers complain about sympathetic snare buzz? Well, head dampening decreases snare buzzing, and this type of muffler decreases it significantly. It's really amazing, it really is. Don't forget to click on the snare drum on the Tuning, Sound, and Design main menu for detailed tuning and snare wire information. Listen. What do you hear? Close listening is a talent, you know. Shh. What do you hear now that wasn't there before? Very good. There are two ways to listen to your drum while tuning. There's specific listening, which is tapping the head at individual tension rod spots while listening to specific pitch relationships. The other perspective is total listening, which is striking the head in various strike regions with the focus being on overall evenness in tone and sound, while paying less attention to the exact pitch relationships. I find this technique to be the most useful. This is like the difference between listening to the orchestra and listening to the violinist in the orchestra. If you don't experience the entire orchestra, then what's the sense? When all is said and done, the overall sound is what you relate to as a drummer. The more you experiment, the more your taste becomes selective. Sorry, there are no shortcuts here. You just got to work at it. The strike zones. Check out the head graphics. Hey, maybe we should make all heads look like this. Remember, it was my idea. Let me demonstrate the strike zones. Mount the drum on the stand now and begin hitting it in the center strike region. Detune and retune various key rods quickly in an arbitrary fashion. Listen closely to the way each key move affects the sound. Certain key moves are going to be more effective than others. The game here is to find the magic key. And unfortunately, there isn't a science to this. I wish there was, but it's strictly hit or miss. Again, this relates back to the drum head being the variable. Once you're satisfied with the sound, continue by moving around the various strike regions to check overall performance. Again, strive for evenness in each strike region. You may have to shift the head somewhat. I use two different techniques. Number one, locate, tap, turn while listening. Okay? Now, number two, locate, tap, then listen. Let's go to the bottom head. While striking the center zone of the batter head, begin gently tweaking the bottom head key rods while listening to the effect. In the case of the snare drum, you will hear the overall pitch of the drum changing slightly. Mess around until you find something that really suits your taste. Once you're satisfied, turn the drum over and do a visual inspection for evenness, making necessary adjustments. Quick reminder, always tune below then up to the pitch you are targeting. Tune times if you want to learn how to tune. This is the real challenge. Due to low head tension in tom-toms and exact pitch relationships, toms are much more sensitive to tuning than bass drum or snare drum. If you want to learn how to tune the toms. Touch tuning works beautifully on toms. When it comes to the toms, the head is merely floating on the bearing edge, hardly touching it. You want to be sensitive. Now use the snare drum touch technique we talked about previously, except apply much less downward pressure on the counter hoop. In this case, you want to apply far less pressure on the hoop than you did on the bass drum and the snare drum. Oh, this is good. Head scratching technique. Wow. Now, place your middle finger up in the air. Oops, I'm sorry. You'll be doing that if you'll be going to be doing that to me if you can't get your drum tuned. I meant place your middle finger on the surface of the head and scratch the head. Like this. This is an excellent way to hear specific pitches in the strike zones or in relationship to top and bottom heads. On to eye tuning. Let's get under that light source again. This is where you can actually view the head vibrating and locate any distortion in the film. Slowly rotate the drum while focusing your eye on the circumference, that would be the edges of the head. Look for dimples or distortion in the film. You might have to reposition your light. Let's try to get rid of that distortion by tensioning down the rods near that area. If that doesn't work, then tension a key rod at the opposite side of the head and see if that eliminates the distortion. If all fails, then move to the 12-3 head check technique. Pay attention! The 12-3 technique is important. When you have to apply excessive tension at a particular tension rod location to eliminate head dimpling, you have a problem. With the light view, locate the position of the dimples on the head. Use a marker to spot that location. Now loosen all the tension rods, but do not remove them. Rotate the head 90 degrees from 12 o'clock to 3 o'clock, the 12-3 technique. Now retune the head and view the spot you marked. If the dimples still appear at that marked location on the head, then the head is the problem. If they disappear or appear at another location along the perimeter, then there's a problem with the shell. By repositioning the head, you may get better performance as well. If the head sounds the same in both positions, then the drum is usually the culprit. On the other hand, if the head sounds better in one of the two positions, then the head is screwy. But you found a better fitting position on the shell, so the head sounds better, the drum sounds better. You're making the best of circumstances. I use this as a process of elimination when I'm doing research testing. Are you with me on this? Come on, I hope so. Ever get a new drum head and you put it on your drum and you can't get your drum tuned up, it just doesn't sound the same? Well, in general, if you're experiencing tuning problems, rotate the head. Retune it before you dump it in the trash or kick a hole in the wall. Know where your drum head is at. Wake up! I can't believe I'm saying this, but don't use your intuition. Wow, that really hurt. Equalized tuning is by far the single most important technique I use. This method equalizes tension pressure applied to the head, no matter what condition the drum is in. I'm going to repeat that. No matter what condition the drum is in, you can rely on this technique to make the very best of circumstances. The 12-inch drum is the best drum to practice on. EQ tuning is a method to detect which way to shift the drum head. The only requirement is to distinguish between high and low pitches. Your instinct is to tension the rod that produces the lower pitch. Let me repeat that. Your instinct is to tension the rod that produces the lower pitch. Well, that's not always true. Let me demonstrate. I'm tapping the low pitch side. Now I'll gently turn the drum key back and forth. Did you notice the pitch hardly changed? Now, move the key to the opposite side, and while tapping the low side, move the same key. Did you notice the pitch go up instantly? This means the head needed to be shifted to the opposite side. Sounds screwy, but it's the best method in determining equal tension. Now move around the strike zones and recheck for evenness. Please notice I'm making very subtle and quick drum key moves until I'm satisfied with the drum sound. Any scores? Now let's shift to ear tuning. Even out the tuning of the bottom head. Be careful not to pitch it up too high. Start by establishing the lowest tension you can get. All the wrinkles should disappear and the head should fully resonate when tapped or scratched. Next, flip the drum over And let's tune the batter head around the same pitch. That's pretty close. Okay. Ever watch a guitarist use harmonics to tune a string? They pick two strings and tune one to the other. As the two pitches get close to each other, the vibration of the harmonics becomes slower and slower until they finally stop when a single pitch is achieved. Hearing harmonics from a drum is a little more difficult, but in a way, similar. After a while, you'll develop an ear for it. Next time your guitarist is tuning up, ask for a demonstration and listen carefully. Now, let's mount the tom onto the stand. While striking the center zone, select individual key rods and quickly loosen and tighten them back up in pitch. Like this. Strike the drum, then quickly make your key move. Listen closely to the resonance of the sound. Shh, shh. Listen. It's the sound you hear right after striking the head. The more you're able to hear a single pitch, the more even your tuning is becoming. Let's do that again. Listen carefully. Your key movements should be quick, deliberate, and precise, while paying close attention to the sound. Here, watch me. Please notice that I use combinations of the locate, tap, listening technique we discussed. I will jump around until I find the best results. Once the batter head sound is nice and even, jump to the bottom head and make very minimal key moves while striking the batter head. Let me repeat that. Go to the bottom head and make minimal moves while striking the batter head. I like to tap around the perimeter of the bottom head to look for a low spot. Then I mess with that particular key rod, or the one on the opposite side. Up to this point, it's best to hit the drum lightly, but the final test is to give the drum a good hit in the center. Back off, hit it, listen, and hopefully you'll be smiling. Okay, we're coming into the stretch now. Here's a little tip. Move the tom up and down the tom arm. There is always a spot where the drum resonates the best. Sometimes it's all the way up, and other times it's near the end of the rod. Here's a little reminder, by the way. Like the bass drum, a single key rod move up or down can often open a drum up or dry it out. Oh, while we're on it, small and large diameter drums like the 8-inch, 14-inch, and 16-inch drums are extremely sensitive to single key rod adjustments. Be gentle. You can get just the right tuning from a single key move. Okay, all right, this is the last tip, I promise. If you're using mufflers on toms, like tuning with snares on, tune your toms with the mufflers on. You may as well tune your drum exactly the way you're playing it. Now check out toms on a Tuning Sound and Design main menu for more details. I would like to thank my good friends at Penfield Productions and Warner Brothers Music Publishing for making this video possible. Also, thanks to my wife Joanne for supporting me when my anal workaholic personality takes over. We're going to Disney World! Before I say goodbye, let's take a few seconds and review. Touch, eyes equal ears. High and low pitch recognition, the 12-3 technique, EQ tuning, head scratching, total listening, 3 key facts, the drum head factor, and last but not least, know where your drum is at. My last reminder is to take a few moments, periodically sit on the floor and recheck your drum. Think of it as preventive maintenance. It's time well spent. Well, that about wraps it up. And I only want to hear success stories, so write to me at bob@drumframe.com. See ya, and thanks again.